exponents, right? I have 2. I raise it to the power of 1 and I get 2. 2 to the power of 2 gives me 4. 2 to the power of 3 gives me 8. So in going from an exponent of 2 to 3, my value jumps from 4 to 8, right? And I miss all the other numbers completely. But what if I wanted to raise 2 to an exponent and get a value of 6? What then? What can I raise? What exponent, right, should I raise this number to in order to get a 6, right? So in other words, 2 to the power of what would give me 6? 2 to the power of what would give me 13? 5 to the power of what would give me 42, all right? 27 to the power of what would give you 243? Or 1 over 3 to the power of what would give you 9, okay? This is what question the logarithm answers, all right? So that's a logarithm. So to answer this question of 2 to the power of what is equal to 6, we need a logarithm. And the way we write that is this. So log base 2 of 6 is what? Now, if I were walking down the street and I happened to see that on a billboard, log base 2 of 6 equals what? Okay, I would say, oh, somebody wants to know 2 to the power of what equals 6. Okay, so what if we saw this one? Log base 3 of 7 equals what? What question are they asking us? Yeah. 3 to the power of what equals 7, right? That's the question they're asking. If I have log base 4 of 27, what equals what? What question am I asking? Yeah. Mm-hmm.
4 to the power of 1 equals 27.
Right. Okay. So this question mark then stands for what? It stands for an exponent. Okay? This question mark stands for an exponent. So if you were walking down the street, all right, and somebody tapped you on the shoulder and said, hey, what's the answer to a logarithm? What would you say?
Exponent.
An exponent. That's what a logarithm is. A logarithm is an exponent. Okay? That's what it is. Now, if you remember that, man, you will have such an easy time in life. Okay? Just remember that a logarithm is just an exponent. Okay? So here, if you want to color code it, if I have log base b of x equal to y, what is that? Well, now I'm saying b to the power of y is equal to x. B to the power of y is equal to x. Okay? Now, if I have a power, so suppose I have 2 to the power of 3, right? What is that 2? What label? What's the name of that 2? It's a base. And what about the 3? It's an exponent. All right? So in the logarithm as well, that same base, right? B is the base, it's called base. So log base b of x. All right? Log base b of x. So okay, so let's go here. Remember that the answer to a logarithm is always an exponent. All right, so first off, let's write each of these in exponential form. So we're given logarithmic form, and we want exponential form. All right, so let's identify what we have here. What is the label for that number 3? What is that called? That's a base. And the answer to a logarithm, which is that 2, is always a what? An exponent. So look, if you now have that, it's so easy, right? Because that's the base, that's the exponent. There is only one thing to do with a base and an exponent, and it's just 3 to the power of 2, and that equals 9, which is the argument of the log. Okay? If you want to get technical about it. All right, so how would we write b in terms of an exponential form? In exponential form. Yeah, Ryan.
10 to the power of -2.
Equals
Over
1 over 100. Whoopsie. What about this next one? How do we write this in exponential form? 3 to the power of 6 is equal to 729. Okay? Any questions? Any questions? No? Okay. So now let's write each of these in logarithmic form. Again, the 5 is the base, and this is the exponent, right? And how does a logarithm look? It's always log base b of something equals the exponent. So log base 5 of 125 is equal to 3. Okay? So when I see this, I say, oh, yeah, 5 to the power of 3 is 125. 5 to the power of 3 is 125. All right? 5 to the power of 3 is 125. All right, what about that one? How would I write this one? Log base what? 27 of equals 1 over 3. Yeah, obviously, because 27 to the power of 1/3 is equal to 3, right? 27 to the power of the exponent is equal to 3, okay? And what about this one? Log base 6 of 1 over 216 equals -3, okay? Alrighty. One of the most direct applications of logarithms is the Richter scale. What does the Richter scale measure? Earthquakes, right? So you might have an earthquake with magnitude of 5.0, you might have an earthquake with magnitude of 4.0. Well, what's the difference between them? Well, it turns out that it's an application of logarithms. Okay, so the Richter scale measures earthquake intensity. The increase in intensity between each number is 10 times. So if I have an earthquake with magnitude of 4, and then I have an earthquake with magnitude of 5, the 5.0 earthquake is actually 10 times more intense than that of the 4. Okay, so it's logarithmic, see? In going from magnitude of 4 to 5, the intensity is 10 times higher. So if I go from 4 to 6, how much higher? 10 times 10, 100 times higher. Okay, yeah. So an earthquake with a rating of 7 is 10 times more intense than that of 6. The intensity of an earthquake can be modeled by y equals 10 to the x minus 1. All right, where x is the Richter scale rating. So x is the Richter scale rating, meaning it's the it's the 4.0 and the 5.0 and so on, right? That's what x is. All right, the largest recorded earthquake in the United States was a magnitude of 9.2 that struck Prince William Sound, Alaska on March 28, 1964. Oh. Wait a minute. Okay, you know what? When I was copying this, I thought I fixed this, but I guess I didn't. Wait a minute. Okay, erase this. Use the information to find the intensity. All right? Use the information to find the intensity. All right. So we said that the intensity is modeled by this equation. Y is equal to 10 to the power of x minus 1. Okay? So what is x? X is the Richter scale magnitude, right? In this problem, how much is x? 9.2. So x is equal to 9.2. So y is equal to 10 to the power of 9.2 minus 1. 10 to the power of 8.2. All right? Which is how much? Does anybody want to plug that in the calculator for us? How much? 158 million.
489,319.2.
That's the one. Okay? So that's the intensity. All right?
How is that measured?
Huh?
What units is it? This is find the intensity.
It's not joules. I'll get back to you. Okay. Write an equation of the form of for the inverse of the function. Okay. Huh? Right. So now look at this. This equation, right, is in exponential form. Here, we want it to be in logarithmic form. So remember how in the last chapter we had f of x and we had to find f inverse of x? Well, now we have this as my y. I want to find the inverse of y. So the inverse of an exponential function is a logarithmic function, right? So we're going to take now this equation, write the inverse of it, and that's going to be a logarithmic function. So the equation is y equals 10 to the power of x minus 1. So we switch x and y. All right. Now, can we write this as a logarithm? Right? How can we? This is a base. This is an exponent, right? I have 10 as my base and I have an exponent. So it'll be what? It'll be log base what? Base 10 of x equals y minus 1. Okay? And now can I solve this for y? Log base 10 of x plus 1 is equal to y. And wait, sorry. So this is f inverse of x, or initially it was not f, but y. So y inverse of x is equal to log base 10 of x plus 1. Okay? No, because it's not, it's just saying to write the equation, not necessarily for this particular earthquake. It gives you the form, it just says, because this is the first time we're doing this, it's telling you to get that equation and write it in logarithmic form like this. Get it into a form that looks like this. Okay?